And we're going to be talking in this chapter about things having to do with linear equations, the same equations we've been working on, linear, okay, means line equations, except for now we're going to be talking about them in what's called two variables. And one thing you're going to find is as you go through algebra with me, I'm going to tell you lies all the time, okay? Last chapter, I told you you cannot solve an equation if it has two variables. I said, so never use two variables. But in this chapter, you find out that that is a lie. Well, I mean, it's kind of a lie. There are ways that you can solve them, and there are what ends up happening is you get like a group of answers, a group of possible answers, but you can't get one specific answer if you have two. So I kind of lied to you. I kind of didn't lie to you. Okay, so I try to be honest with you, but sometimes I can't give you all the information because it would blow your mind at that moment, and I don't need your mind blown at that moment. I need you to focus on what I'm asking you to focus on right there. So you're going to be feeling like, Mr. Steve, you're lying to me, and I'm not. Okay, I'm not. I'm telling you the truth for that moment that you need it. Okay, so now we're getting to a point where we have two variables. So what are we going to do with these? Well, let's kind of lay a little bit of groundwork. This lesson here is going to be a two-part lesson. So let's lay the first part's going to be just me laying the groundwork, me giving you some vocabulary, me kind of explaining some things that will get you to where we need to be. All right, first thing, go ahead and look down here at the board, and I've got the word plane written down. Now, we're not talking about an airplane. We're not talking about something that you fly over the ocean on, okay? This is a plane, a surface, I've got that word in quotes, that extends indefinitely in all directions. Now, technically a plane isn't a surface. It is and it isn't, because a true plane has no depth to it. As Euclid described it. But for you to understand this, the easiest way for me to tell you is it's a piece of paper, okay? I got a little piece of paper right here with some stuff on it, and it's just a flat piece of paper. Now, a piece of paper actually does have depth to it. It's not very thick, but it has some thickness. But the idea of a true plane is that it's flat and it extends. Now, the other downside to using a piece of paper as an example is it doesn't extend in all directions indefinitely, but you can think of it as something that keeps going, never stops, just like a line, okay, in all directions. So it just keeps going, but it's in one plane or one surface, okay, like a flat surface, a tabletop, a piece of paper, something that's flat, okay, that's a plane. In your book, oh, by the way, we're on page number 92 in your book. If you're looking for where we are, page 92, you will see a picture of a gentleman. His name is, it's French. He's a French mathematician. His name is René Descartes. René Descartes. Okay, and so if you hear somebody say Descartes, say, no, it's not the way you say his name. Okay, René Descartes. And René came up with some things, and he developed some things with these two variable linear equations. And so much so that he actually got the Cartesian plane. Do you see it? C-A-R-T in his name, C-A-R-T, right there from the middle of his name. Descartes, the Cartesian plane, and it's named after him. And everybody calls it the Cartesian plane. It's just the name of the thing. Now, a technical name is a rectangular coordinate system, okay? But everybody calls it the Cartesian plane. And I'm going to switch this over real quick here because I want you to see this. The Cartesian plane is typically done on what we call math paper or graph paper, okay? And so you can see these little lines in it. Every line that goes up is one space. And so if you're going to be going up the Cartesian plane, you'd have 1, 2, 3, 4, 5, 6, okay? If you're going across 1, 2, 3, 4, That one didn't look so good there. 4, 5, 6. There we go. If you're going down, 1, 2, 3, 4, 5, 6. And if you're going to the left, 1, 2, 3, 4, 5, 6. We just did 6. We could keep going. Remember the plane, it's a plane, so it goes indefinitely. It goes, to infinity in all directions. And so what we have here is we have what's called the Cartesian plane. So every one of those little markings is 1. And 1 what? 1 unit. What is 1 unit? It could be inches, it could be miles, it could be feet, it could be just nothing. It could just be somebody saying this is 1 unit. So you can measure them. You don't have to measure them. It's just each spot is 1 unit away. And so the whole thing works on the idea of the same space, the same number of units for every line on the Cartesian plane. Now, what we'll do is, let me go ahead and take those back off there real quick. I think you can see those little blue lines, but I just wanted to show you that real fast. All right, so a couple things about the Cartesian plane that we have to know. The first thing is there are what's called quadrants. So, quadrant. Now, there are 4 quadrants. So this is quadrant number 1. This would be quadrant number 2. This is quadrant number 3. And this one over here is quadrant number 4. Now, if you noticed, I used Roman numerals there, and that is the way that you're going to see the quadrants numbered. So you're typically not going to see 1, 2, and 3 in the regular numbers. You'll see 1, 2, and 3 in Roman numerals, but they just means 1, 2, 3, 4. Okay, it's just 4 quadrants. That's very important for you to know. I mean, very, very important. And it's important that you know which one's which. So this one is 1 going counterclockwise. This one is 2, 3, and 4. And that's very, very important that you know that order right there. One more thing about these is, and I'll get to this in just a second, a little bit deeper and go into exactly why, but I want you to know this. So this one here is called the positive quadrant. Positive. That's quadrant 1. Quadrant number 2 is what's called the negative positive quadrant. The negative positive quadrant. That guy looks like he's doing the wink emoji, okay? So quadrant number 3 is called the negative quadrant. That guy is sleeping, I guess. So the 4th quadrant, maybe you've already figured it out. The 4th quadrant is the positive negative. That's the other eye winking, okay? And so there's your 4 different quadrants. Positive, quadrant 1. Negative, positive is quadrant 2. Negative is quadrant 3. Quadrant 4 is positive, negative. Now I want to show you something that this doesn't really impact you at the moment. This is going to impact you later. But these 2 quadrants, quadrant number 1 and quadrant number 3, are positive quadrants. Okay, some of you are thinking, you have lost your mind because quadrant number 3 is negative. That's a negative quadrant. No. What happens when you have a negative times a negative? You get a positive. So what's happening in quadrant number 3 is because there's 2 negatives, that makes it a positive quadrant. And again, that's not super important for you right now, but quadrant number 3 and quadrant number 4, quadrant number 2 and quadrant number 4, those are negative quadrants. So this is going to be important for you in a couple days, and then in the future for sure. Algebra 2, pre-calc, all those different things, trigonometry. You need to know where the positive and negative quadrants are and what each quadrant kind of means. And we're going to run into all kinds of different things with this, but the things that you need to know right now are positive, quadrant 1, negative, quadrant 2, negative, quadrant 3, positive, negative, quadrant 4. You need to memorize those. Those are super, super important. Now, one more thing that I failed to mention, I should have mentioned this, but this is also very, very important, is this line right here. This line right here is called the x. That is the x line. Okay, we'll just call it line right now. And this line up here, this one that's going up and down, this is called the y line. Now, they have a special name. Of course they do. Everything on here has a special name. And they are called the axis. So the x-axis and the y-axis. Okay? So x and y axis. And this is like the main one right here. Okay, there's something special that happens right here in the middle, okay, where the two axes meet each other. And that point right there in the middle where they cross, the x and the y, is called origin. Origin, okay? And it's the beginning point. It's the origin. It's where it originates, okay? And so that point is actually called 0, 0. It's 0 on the x and 0 on the y. If you think about it, we haven't moved. We're right where we start. Whenever you graph, whenever you put something down on this plane, you're always going to start right there in the middle at origin. That's where you begin counting from. Okay, so that point, super, super important right there, right in the middle, is called origin. Now, a couple other words that are somewhat important at this point, not really. I want you to know them. I want you to start practicing using them. You might see them on a quiz or a test, but this is the words right here, abscissa. The abscissa is the x-axis, okay, the abscissa, and the ordinate is the y. So the y-axis. And really, here's what those really kind of mean. You can see those in your book there on page number 92. But those are like the distance that you're going up or the distance you're going over. So the ordinate is the amount of spaces you go up. The abscissa is the amount of spaces that you go over. And we'll kind of talk about that a little bit more as we go. But I think that's about everything that I have for you there on that page number 92. So I got quadrants, I got the abscissa, I got the origin. I know one that I did not say. There it is. Ordered pairs. There was one more hiding in there. Ordered pairs. What is an ordered pair? Here's an ordered pair. You have an x and a y. And this is the way that we write them. The x is always on the left-hand side, and then a comma, and then the y is always on the right-hand side, and then we always put these, parentheses there, okay? So the x and the y ordered pairs, And you always have the parentheses. You always have your x first, then your comma, then your y. That's the standard form of an ordered pair. Okay, so here's what I've done. I erased everything out of the Cartesian plane, and I have put some ordered pairs over here. And we are going to go ahead and we're going to graph those ordered pairs. We're going to put them where they belong on the Cartesian plane. So let's start with this one. Now, when we look at that one, we have to remember when we go down here that the ordered pairs go x and then y, x and then y. So this first number is going to be our x number, this 3. So here's what we want to do. We want to count over 3. One thing that I'm not sure that I mentioned is when we go to the right, we're going positive. When we go to the left, we're going negative. When we go up, we're going positive. And when we go down, we're going negative. Okay, so that's how you know which way to go. Up is positive, right is positive, down is negative, left is negative. All right, so let's go ahead and try this. So let's take and do 3. So we would start at origin. Don't forget we're starting at origin. 1, 2, 3. Okay, so we go 3 over, 3 positive 3, and then we're going to go 2 up. 1, 2. And so our point is going to go right there. And how do we know how to do it? Well, we went over 1, 2, 3, and we went up 1, 2. Okay? And so there's our point. So we'd erase all this other stuff, and we just put the point. You don't have to put the little marks where I move it over. Okay? All right, so that's 3, 2. Okay, so let's do the next one, negative 3, 4. Negative 3, 4. So I'm going to do this one in green. I want to go over 3 spots to the left. Why to the left? Because I have a negative, and so I'm going to go to the negative side. 1, 2, 3. Okay. And then I want to go up 4. Why up 4? Because the y, right there, the 4, is positive. So I'm going to go up 1, 2, 3, 4. So that's where my next point is going to be. And then I will do the next one in yellow. This one is the negative 4, negative 3. So now I'm going to go negative 4. So again, I'm going to the left. 1, 2, 3, 4. And I'm going to go down 3. Why down? Because down is negative on the y. 1, 2, 3. And so my point is going to go right there. All right. And then the last one, do this one in purple. And we have a positive 1. So 1 over on the x, 1 to the right, because it's positive, and then 2 down, negative 2. 1, 2. So my point would be right there. Okay. All right, so that is how you graph on the Cartesian plane. That blue dot in the middle is origin. That's 0, 0. The pink dot is 3, 2. The green dot is negative 3, 4. The yellow dot is negative 4, negative 3. And the purple dot is 1, negative 2. So if you didn't really understand that, make sure you rewind it, watch it again, and try to figure it out. Okay. All right. That's all I have for you in this part of the lesson. Next lesson, we will actually kind of take it to the next level, and then we'll show you how to actually graph some equations on this line. Okay. All right. We'll see you later. Have a good one. Bye-bye.